I'm going to like to introduce to you my co-speaker right now. He has 2 children, so he's building his own binary tree at home. He's planning to learn ukulele, but he promises not to perform that for you tonight. Yeah, he hacks on the Android components, the Mozilla Android components at Mozilla for our Firefox products. Without further ado, Sebastian Kaspari.
Yeah, thank you. Yeah, with me is Colin Lee. Some fun facts about Colin. He was born in South Africa, started developing Android apps on a G1, and is now an Android engineer at Mozilla as well, working on Firefox Preview, our new Firefox for Android. And about the beginning of last year, Mozilla started to split the functionality of its Android browsers into standalone Android components. And at the beginning of this year, we started to rebuild Firefox for Android from the ground up with those components. And in the talk today, we want to talk about why did we do this? Okay, we don't have slides, apparently.
Uh-oh.
I show slides without them.
Let's see if I can...
Oh, there they are.
There, sorry.
That's Firefox Preview, by the way. So in this talk today, we want to talk about why did we do this? How did we do this? Then we want to live code a browser here on stage, if the demo gods want to. And then we want to show some of the cool Kotlin language features that made this great to develop. So let's start with the why. For the longest time, Mozilla had only one major Android application that it maintained, and that was Firefox for Android. It's now almost 10 years old, almost as old as Android itself. Then in 2017, we started to build a new browser called Focus for Android, a privacy-focused browser. And it was a completely new app, new repository, new tooling, new CI. We only borrowed some code from Firefox for Android. Fast forward half a year later, a different team inside Mozilla developed something called Firefox Rocket, which later became Firefox Lite, a lightweight browser for the Asian market. And they did this by forking the code base of Focus and turning it into a full-featured browser. Yet another half a year later, a team inside Mozilla looked at developing apps for Amazon devices that also run Android. And the first app was Firefox for Fire TV. Again, it was a fork of Focus, and they turned it into a browser that works well on TVs. And again, later, this was forked into Firefox for Echo Show devices. And you can already see that this path is a little bit problematic if you continue this with forks of forks. And it just does not scale well. So we wanted to fix that. And some of our goals were we wanted to share code between our apps. Whenever one team builds a cool new browser feature, then we want to be able to use this feature in all our browsers. And we wanted to reduce the maintenance overhead. If we fix a bug in one browser, ideally this bug is fixed everywhere, and we don't need to chase this bug through all the code bases. We wanted to have clear architecture boundaries. Features should be isolated from each other and not interfere if they are not designed to do this. And finally, if we want to build more apps or experimental apps, then this should be fast and easy to do. So we came up with this solution. Let's just build independent reusable components, and then we can use them if we build new apps or if we want to run some experiment with some demo build. But what does components actually mean in this context? For us, it meant we wanted to build independent open source Android libraries. And we wanted to define an Android-first extensible application architecture, which means we wanted to define how you can use those components to build a new app from them. We wanted to have minimal cross-component and third-party dependencies. Whenever you pick up one of the components, it shouldn't mean that you have to use the whole tree of components. And when you pick just one component, it shouldn't mean you need to use some third-party framework that we just liked at the time we wrote the component. They should be customizable and pluggable. Every app is a little bit different, so you need some kind of configuration to fit the component to your needs. But sometimes that's too complex or just not feasible, and then you should be able to replace a component with your own implementation. And finally, we wanted to distribute them as AARs via a Maven repository because that's just easy to consume in any Android app that uses Gradle. And of course, we decided to write them in 100% Kotlin from the beginning. Well, and some Rust code. In In situations where we wanted to share our code beyond Android and use it also on iOS, Windows, Mac, Linux, and so on, we decided to write this code in Rust and only add a small layer of Kotlin on top, because then it's easy to use from the Android world. So let's look at how we did this. And for that, let's look at some of the components. And at least in a browser, the most important one is a browser engine. Just to recap, a browser engine usually comes with its own network stack. And it uses this network stack to pull the resources of a website like HTML, CSS, and JavaScript from a web server, and then creates a visual representation of this website. And it's interactive, right? You can scroll it and click on links and so on. On Android, you can choose between multiple browser engines. The most obvious and popular choice is WebView because it's integrated into Android. It is on every Android phone already. Mozilla develops its own engine called Gecko, and we also provide this as an Android library called Gecko View. But there are others. One example is Servo. It's an experimental browser engine written in Rust, and you can also use it on Android if you want to. For some browsers, we use WebView, but for most of our full-featured browsers, we use Gecko View. I want to show some of the features of Gecko View that make this a great choice for at least browsers. First of all, since Gecko View is just an ordinary library, you pick the version and add it to your build configuration, which means you are in control of the updates. WebView updates itself, and that's great for security, but it can also lead to surprises if the engine just changes without you knowing that it's going to change. Gecko View is also multi-process. Websites are isolated from your main app process, and if the engine crashes, you can recover from that and it doesn't need to crash your application. One super cool feature of Gecko View is that it separates between a session or a tab and the view, which means you can load websites completely off screen and later decide to maybe render this on a view. And when you want to switch tabs, like in a browser, you just render different sessions on the same view. It comes with a private mode where it doesn't save any of your browsing session to disk, something that WebView used to have too, but unfortunately it doesn't have it anymore. It supports a limited set of web extension APIs. Web extensions are usually developed by third-party developers to add more features to the browser, and you can do this with Gecko View too. And finally, it comes with some advanced browser features like tracking protection, where it blocks trackers and ads on websites you visit. So let's look at this from the component level. There are multiple choices of engines, which means we want to be able to switch between them or decide which one is the right one for our product. And we did this by defining something we call concept components, in this case, concept engine. And the interesting thing is that this concept component doesn't actually contain any implementation. It only contains the interfaces and data classes that define how we want to interact with an engine. It's basically an abstraction. And then we provide different components that actually implement those interfaces. For example, browser engine system uses the system WebView, and browser engine Gecko uses Gecko View. So this means as long as other app code and other components only use the interfaces from the concept component, it doesn't matter which engine you pick, and you can even switch between them. Another important piece of a browser is the toolbar. It needs at least to allow you to edit the URL, and it also needs to display the URL of the current website. So it's a great candidate for a component. And we followed the same approach. We first defined a concept component that defines how we want to interact with the toolbar, with interfaces and data classes. And then we provided one implementation called browser toolbar, which can be configured to whatever you need. But if the app wants to do something completely different, it can implement this itself. The app team can do this. And as long as they use the interfaces from the concept component, it means it will just work with all the other components without any additional code. So let's assume you use those two components, an engine and a toolbar. Then you might end up with something that looks almost like this. Very big view that renders the website, and in this case at the bottom a toolbar that shows the current URL. I'm omitting some glue code here because whenever the engine loads a new website, it needs to tell the toolbar what URL to display, and if the user types in a new one, it needs to tell the engine to load this website. We solved this by something we called feature components. They know how to connect components together, but for the sake of the example, I will just omit them here. So if you have this, are you done now? Is this a browser? Well, kind of. You definitely can use it to browse the web, and it will satisfy a bunch of use cases. But if you have ever built an app maybe with WebView and you wanted to use some more advanced web features, then you might have noticed that there's a lot more you need to implement yourself. I want to give you just some examples. Maybe you want to handle downloads in your app, and then you might want to show a dialog when the user clicks on a download, or while a download is in progress, you might want to show some notifications. Or if you long press on a link, you might want to show a context menu, showing you options like open this link in a new tab. Or while you are typing in the toolbar, you might want to show results from a search engine or from your local history. Or on media websites that show video content, you might want to use that and show a media notification on Android that allows you to control playback even if the app is in the background. And on websites that have a lot of content to read, like articles, you might want to turn this into a reader view. That is just easier to read on a mobile phone. So what we did is we wrote components for all of those things and for a bunch of more. Way too many to actually show them all on this slide, and way too many for this talk. So instead, let's actually use them to build an app right now.
Awesome. Thank you, Sebastian.
Yeah.
So if you guys have been wondering why I was quiet so long, it's because I get to do the fun part of the talk where I get to play like Diablo or Dark Souls on Nightmare mode by live coding a browser for you right now. You know, there's no better way to show how easy something is than to screw it up in a live presentation. We'll just start just to be daring from a brand new Android Studio project. So the empty activity. Let's see, give it a cool name. Hello, KotlinConf. I don't know. That's fine. All right. Okay, so I'm going to start off here with a brand new empty activity. First off, we're going to want to give it, let's see. We're going to put in a layout here. I want to put this in mode where you can actually see what I'm doing. There we go. Cool. So, did everybody see that okay? I might want to make it a little smaller. All right. Anyway, so here I have a layout. I'm going to bring in, everything is way too big. But what you can see here is I have a coordinate layout, and I'm putting in a Gecko engine. Gecko engine is a instance of our browser engine for Firefox browsers. It's using Gecko View, the new faster engine that we have. We're also putting in a browser toolbar and just two buttons, back button and a forward button. So the first thing we're going to require is we're going to have to bring in a bunch of dependencies. First off, we have these all project repositories. We're going to need some Mozilla Maven repository so that we can access all of these open source components from Mozilla. Then I can go over to the app, and here I'm going to add in a Java 8 dependency. If you don't do this, by the way, things won't work. So please remember to include Java 8. Because we don't want things to silently fail for you. And we'll put in our first batch of components here. So, no, that's not it. So I added a concept engine. I added the Gecko engine. I added the browser session concept. Sessions are tabs, essentially, in our browser. And then I added toolbar, which has like the concept would be like the interface in this case. And then we have the actual toolbar and feature. So at this point, all we need to do is go over to our main activity. And we need to actually add in the things that we need. Sync Gradle for I do that and add some components. So right now we have, I added an instance of the concept engine, a browser store, which is essentially a MVI or Redux style store of our browser related state. There's a session manager, which is, sorry, that stuff's in the beginning of the way. Session manager is what manages our tabs for us, and session use cases would then allow us to control creating and destroying tabs, for example. Finally, I'm creating an instance of the app just to access this, because I'm not going to do a Dagger thing live on stage for you right now. That would be truly crazy. Let's go ahead, and I think I just need one more thing, and I can actually run this. So we're going to want to create a session. What I did is I warmed up the engine. This is really, let me see if I can fix this. 1 sec here. Font sizes are massive. Can't see anything. Okay. 1 sec, guys.
That's actually big enough, maybe.
You can read that, okay? All right, we'll just leave that mode altogether. We can read it that way. There you go. So I added an engine and I'm warming it up. That's just doing initialization stuff to make sure that we're ready. You could do that easily in application on create. But what we're doing then is we're going to create a session, a engine session, and then render that to this view. This is referencing the actual Kotlin synthetic engine view. And finally, we're going to add a session to the Mozilla website, select it, and pass in the new session I created here. So this is all it takes. There's one more step I forgot, and that is I have this demo application. I'm just to get the dependency injection right. I'm going to put that on the manifest and name my application. And this should run. Moment of truth. Oh, I got to do one more thing. Let's show the UI. I think it's running. Okay. Just compilation is a fun thing. Anyone know any good jokes? There we go. And if everything works out fine, it should pull up the Mozilla webpage once the Wi-Fi kicks in. And there we have it. We have the basics of a browser. Now that's not very exciting. I can't actually, it's not using the URL bar yet. At this point, the backward and forward buttons aren't wired up. So let's add in some toolbar support to this sucker. Make it something useful. First off, I'm going to add in a couple more features. This is a toolbar feature and a session feature. I'm going to then create instances of them here. All I'm doing is I'm passing stuff to the constructor. Very simple. I think that the components in general are fairly easy to just wire into a program. We want them to be easy for you all to use. At this point, I need to have a way to start and stop these features. There will be a better way to do this. I'll show you in a second. But for now, we're going to do it with actual direct calls to unstart and unstop. In addition, we're going to add some buttons. So we have listeners to go backward and forward in your history. And at that point, I think we can demo a toolbar working and watch for it to load again. There we go. You see now the toolbar is actually showing URLs. It's showing lock icon. We're getting, the ability to browse backward, forward, all that fun stuff. So all of that is now working. We can actually type things into the URL bar, and it should browse to them. Sure, something. Anyway, so let's try and do something more interesting. We have these capabilities we've added to our tools. We can add tracking protection. We can add a reader view. And I'm actually going to add something we call the awesome bar, which is basically just a nice search bar that allows you to, say, automatically include your clipboard competence or your auto-completion or other kinds of things. Searches from past history, that kind of stuff. You can add providers for each of those. So that's all working fine, dandy. We're going to jump over here and we're going to add in some more components. Oh, great. Cool. If you're wondering why they're not up to date versions, it's because you practice with a particular version and then you're like, this one works. These tools are an open source and they're very, very active development. We're adding new stuff all the time. It's really cool. So I add some more missing dependencies here. Let's see. And add in some components. Cool. So what I added was, obviously, we still have an engine, but now we're specifying a tracking protection policy. So that'll define how we decide whether something is a tracker or not and block it. In addition, we're going to have a request interceptor, which this will be fixed soon. There's a PR to work around, remove this workaround, so things will be fine. But for the time being, that's there to enable tracking protection. We have a client. This is just an HTTP client. In this case, we're actually using GeckoView itself to provide that. We already had the store. We already had Session Manager. So we're adding some new use cases and a thing called Search Engine Manager, which allows us to manage the searches that run through your browser you're creating. So all of that's now wired up. We're going to, by the way, the tracking protection is a big deal. I don't know if you guys are familiar. There was a study recently that found that the top 500 websites on the internet are actually run 2 times slower as a direct result of the trackers. So if you can reduce the amount of tracking, it's not just a privacy benefit, it's also helping us in terms of the speed at which we load sites. So I'm going to actually sync Gradle, and then we're going to add a new layout. So all I've done here, I've added this browser awesome bar thing, which is going to render the auto-completed searches as well as things like our clipboard provider. Again, we still have the engine, we still have the browser toolbar, but I've added the ability to a read button and a font button on the bottom of our very ugly UX that I've been using for this quick, dirty demo. So I'm going to move on here a little bit. We could do something nice now. I mentioned before, we don't need to call on start and on stop for every single feature that you put into your app. That's because we added some Android architecture components that uses the life cycle. So I'm going to add these view-bound feature wrappers, which now requires that I go back here and set these up with the life cycle. Cool. I'll do the same thing here. And at this point, that I can remove the on-start and on-stop because it's handled. Sure. And I'll go down there. Cool. All right, that's great stuff. I'm going to also now add in the feature for the reader view. Again, reader view is a feature that allows you to look at, let's say, a news article and strip away all of the junk and cruft that's making it hard to read, and just look at the article directly. So I'm going to add that in. See, that's what you'll notice here is because of Kotlin, of course, I passed in a lambda. This one is actually telling you what to do when the state of whether the page is readable or not changes, and I'm changing the visibility of the buttons in that case. Let's see. So we're going to wire up the buttons now that I just added. Oops, one thing. Okay, I need to replace that entire unresume here. There we go. So in addition to our back and forward button, we now have a read button, which will then either show the reader view or hide it, depending on the state. And we have a read controls button, which will then show the controls when we click on it. And I think we're just about ready. We'll see. I'm going to set up the toolbar as well up here. Let's add a new function. This one's a little bit longer, so I'll explain for a second. Awesome bar feature, again, is the thing that controls our, as providers for search, history, clipboard, things that can auto-complete into little chips on your display as you're typing. So we're adding a search provider, a clipboard provider, and a session provider. The search, again, is like your autocomplete chips at the top. your clipboards, obviously your clipboard. The session provider allows you to type in something that would match your current session or another tab you have open, and then move you to the existing tab. So that's really handy to have in any browser. Toolbar autocomplete is actually the autocomplete inside of the toolbar. So if you're typing a recognizable URL like google.com, it'll autocomplete that pretty fast rather than having to look up and pick a search result. And just hit enter right away. We're adding an extra display indicator for tracking protection, so we can now see whether or not we're being tracked on a site. And finally, there's a fix me at the bottom. The only reason I put that code in is because at the moment we'd have 3 icons that are identical for tracking protection as a default. And we're going to fix that default. There's an issue and it's being worked on. So I'll do one more thing. I'm going to add a backpressed listener. And this is going to defer to our features, call their backpress listeners, and if they all come back false, we're going to actually go backwards out of the app. So finally, I'm going to hit the magic buttons, jump back to the screen, and we'll have a moment of truth again. And demo the awesome bar and see if it actually turns out to be awesome. I mean, obviously this isn't complete, but we are like role-playing the real development experience of working without Google and Stack Overflow. Here we go. All right, we can now go to, I think there's a link down here that's readable. It looks like an article. I'm gonna click on this one. And now, first, if I hit read, it's going to jump over to that. Somebody use mic. I can actually change, fonts, change backgrounds, all kinds of fun stuff. That's great. But we also added an awesome bar, so I can go to, let's say, CNN.com. Here. Wonder what happened there. Well, anyway, let's see that again. Looks like something to get wired up here. Oh, the setup method. Let's see. I made a method. I never called it. Thank you. Thank you. See, this is why live demos are always fun. It's Mark Gray, and yes. I guess the nightmare mode player character just got destroyed. So. Here we go. All right. So we've got this little red X here, which is telling us that's just the thing I added from the Android framework itself to say that there's no trackers at this point. If I go to CNN.com, now we're getting those little chips on the top. If I were to search for something, if I had something in the toolbar, it would show up there. Also, if I had an existing session, I would find it as well. So I can click on these things, and that comes up. And if I actually go in here, you should see a tracker icon change. There we go. And everything seems to be working now. So there's one other thing I wanted to do. Let's actually, now that we've used all of these fun components, let's actually try swapping out the entire browser engine underneath all of them. So I'm actually going to go back in here, add another Gradle dependency. And sync. And then I'm going to change in the layout. Actually, if you use the generic engine view, it's a little nicer, but then you also have to override onCreate view. So I'm just going to do this directly. Again, quick and dirty, like I said. And then I'm going to change the engine down here in the components from Gecko engine to system engine, which is web view. And now, if I run that, drum roll, please. It's loading. Okay. You probably noticed that there was a slight difference in the tracking stuff, but because of the lists that they use are different with the different browser engine. However, you'll see that all of the features that we now have in the browser are working as you'd expect them to. So yeah, all of these things that you can put into your browser are very, very easy to include. I pulled it off pretty easily with just one little minor missed call. So I'm going to hand it back to Sebastian to finish this out.
Awesome. I guess I owe you a beer because there was no crash. Awesome. Yeah, for the end of the talk, I want to show you some of the Kotlin language features that made this great to develop. After all, that's KotlinConf here. So my personally favorite feature of Kotlin is explicit nullability. It's just so super helpful to be able to explicitly define whether you take in null as a parameter or whether you're returning null, especially if you're writing a framework and if the teams that are using the framework are different teams than building the framework. For some of the other language features, let's look at how we handle state in our app. And we are using a kind of Redux style pattern. We wrote a component for that, surprise. It's called libstate. And in this component, we have a store. And the store contains a state object. It's an immutable state that defines the state the app is in. And the state is just a data class. It's a very concise way to write this immutable state. And it's kind of a tree if you have multiple data classes inside data classes. Of course, the components and also the app needs to know about the current state, and we needed some kind of mechanism to get the current state, but also all state updates. And we did this initially by writing a very verbose but flexible API that we called observe manually. You provide a function that will get invoked with the current state and all further state updates. Then return a subscription object that allows you to resume, pause, or cancel observing the state. And if you use this API, it roughly looks like this. You call store.observe manually, you pass in a lambda that will get invoked for every state, and then you update UI or whatever you want to do with the state. And then at some point, you call unsubscribe. I mentioned this API is very verbose. It works in a lot of use cases, but it's not nice to use. So we looked at options to make this better. Extension functions were a great language feature for that because it allowed us to keep the store as is, plain and simple, and then have those extension methods to iterate on API. So one of the first options we tried is let's pass in a lifecycle owner because then, well, we can cancel, pause, and resume automatically, and you do not need to care about this. In some situations, we noticed that it's very hard to get access to the lifecycle owner deep down in the code, but often we had access to a view. So another API we tried is using a view, and whenever this view gets detached, we automatically unsubscribe from the store. I mentioned that the state is immutable. The missing piece is that, of course, the state still needs to change somehow. And that's possible by the component or app code dispatching an action on the store. For the actions, we used sealed classes. Sealed classes were a great choice because that just limited the options. And we could define the actions we wanted to support. And an app couldn't just invent random actions that we don't support. If we now look inside the store, whenever there's a new action coming in, the store takes the current state and this new action and passes it to the reducer, and the reducer will then return a new state. And the store will keep a reference and also notify all observers. If you go one level deeper, the reducer is just a fancy name for a function. It takes in a state and an action and then returns a new state. As I mentioned, we used sealed classes for the actions, and that was quite nice with the when statement here because it forced us to always process all actions. And whenever we invented a new one, the compiler would actually tell us that we need to implement this here. I mentioned the state is modeled with data classes, and that was great inside the reducer. The state is immutable, so we need to create a new state. If you need to create a whole tree, that can be quite painful, but Kotlin allows us to just use copy and then provide the property and value that we want to change. Type aliases, super simple language feature. We use functions. We also use generics because it's a component that needs to be used in multiple apps. And if you mix that with passing generic functions as parameters to other functions, then it gets very hard to understand and read. And just giving the thing a name makes it just much more readable. So we noticed that in 99% of the cases, I guess, when we got a new state, we wanted to update UI. And initially, we did this by dispatching a coroutine or launching a coroutine on the main dispatcher. But if you do this for every state change and you launch a bunch of coroutines, and especially if they suspend in between, then it gets really hard to understand in which kind of order they are getting executed in. And if you want to update UI, then the order is actually very important. So we looked at other options, and again, used extension functions because this meant we didn't need to pollute the store with all those new methods. We could try those new APIs without touching the store. So the first one we tried was channel. That worked pretty well. We could launch one coroutine, read values from the channel, and process them in order. And then there's no problem with the order because it's just always the right order. Later, when the Flow API became more stable, we switched to Flow. It was just a nicer API for us, and we could make use of all those new operators. But still, we noticed that it's always the same pattern. We create a new scope, we launch a coroutine on the main dispatcher, then we ask for a flow, then we process the flow, and at some point we cancel the scope. So we again created a helper and tried to find a better API. In this case, something we called flow scoped. In this case, we don't return a flow, but you instead provide a function that defines how you want to process the flow. And then we create a scope, launch a coroutine, ask the store for the flow, and pass it to your function. And then we just return a scope because you as the caller still need to define when you want to cancel the whole thing. I mentioned that Flow comes with all those operators, and that is great. We noticed for state updates, we often wanted to have something custom. And one of the examples is that we have multiple listeners to the state, and we don't want to always do something, but only if a part of the state changes that we are interested in. And one of the things we tried is this if changed operator. In this example, we get a flow from the store, we map it to the title of the selected tab of our browser in this case, and we only want to do something if this title has changed. And then in collect, I get the title and can do something like update the UI with it. That was good enough for simple use cases, but in some situations, we wanted more from the state, more information about the state whenever the title changed. And that's why we introduced another version that takes in a transform like map. And in the example below, we get a flow from the store. We say we only want to do something if the selected tab of the title of the selected tab has changed. And then on collect, we get the whole state object and not only the title. In some situations, that could become very complicated. Like we created this beast called filter changed. The best way to explain this is to look at the example. We map the state to a list of tabs, and now we are only interested in the tabs inside this list that have changed. And that's what this filter changed operator does. We map every tab to its title, and then in collect, we will only get the tabs where the title has changed from the previous state. We are almost at the end. So we are 2 people here on stage, but a lot of more people have contributed to this. A lot of teams inside Mozilla, our open source contributors, and I just want to say thank you here. If you want to know more about our projects, those URLs at the bottom here are a good start to know more.
I'll just say briefly, I think like it's very valuable. We love your contributions, and actually we will love to hear about it if you build something using this. certainly we have all these components, and there's a ton of them, and some of them aren't even browser related. So if you find yourself needing metrics or or telemetry, or if you want to have experimentation frameworks, we have all of this in our components, and we love to hear about things you want to see improved.
Yeah, definitely come to us. And if we have a little bit of time left, then we are also happy to answer questions if there are any.